Good evening all. I want to start by thanking all of you for sparing the time to come to this presentation. Thank you all for coming. My name is Chanda Francis from Acid Plant, Assistant Superintendent. I'm here tonight to interact as I introduce Acid Plant. Why is Acid Plant so important? At the end of this interaction, we are going to learn one or two things why it is important to have such a facility. I expect a lot of questions from you and a lot of answers, of course. What is sulfuric acid plant? It is a facility, industrial facility, where production of sulfuric acid is done. Then what is sulfuric acid? A chemical that is so corrosive, versatile, and indispensable chemical with quite a number of application and a lot of influence and impact in a lot of industries. We can talk of petroleum refinery, we can talk of manufacturing, we can talk of cars, battery cars, we can talk of drugs, agriculture, fertilizer. In all these areas I've talked about, one thing is common and true: sulfuric acid. It has to be handled with care because of its corrosive nature. In terms of the capacity, plant capacity, our total capacity of our sulfuric acid plant is 680,000 metric tons per year. Configuration of our plant, we have a 3+1 configuration, double contact, double absorption, which I'll fully explain later on what the DCDA means. The sources of our raw material, in this case the primary raw material, which is SO2, sulfur dioxide. Our sulfur dioxide is coming from Smelter department, from both the ISA and the converters, PS converters. When you talk of the products, what products do we produce as acid plant? We have 4 products that we are producing as a department. We have 4, 98% sulfuric acid. We also have bismuth oxchloride. We also produce gypsum. We also produce copper cathodes from electrowinning section. Quickly, I'll try to run through the operating sections of acid plant. We have the major 4 ones. In this case, we have the dust collection, famously known to be ESP, that is electrostatic precipitator. So we are using electrostatic precipitator to trap the dust from the off gas, where we use electricity direct current to trap the dust. We collect it, we discharge, then we take to feeding plant. The other dust we take to bismuth leaching plant for value addition as well as for metal recovery, which I'll talk about shortly. We also have acid making. This is a section where we produce sulfuric acid. We are using contact method to produce sulfuric acid. We also have a waste acid treatment plant. It's a section of acid plant. We don't want to pollute the environment. All the waste acids that we generate, we pump to a section called waste acid treatment, where we neutralize with lime, that is calcium hydroxide, to make gypsum. The 4th section is a bismuth electrowinning section. We do not want air pollution. We capture that dust, then we dissolve it, we leach it, we filter it, then we send it to electrowinning, where using electrolysis we get copper cathodes. We get bismuth oxchloride as a compound. So that is a very important value addition. We are going to share and discuss the following words, terminologies that are commonly used in acid plant. The first one being absorption. This is to take in something or suck up something or soak up something, either through chemical means or physical means. In the context of acid plant, this is the process we use to dissolve SO3, which is sulfur trioxide, in sulfuric acid to make oleum or fuming acid or pyrosulfuric acid. Catalyst. It's a substance, chemical, that speeds up, to speed up a chemical reaction without itself been consumed or rather changed permanently in terms of its chemical composition. That is a catalyst. In the case of sulfuric acid plant, we have our famous catalyst that we are using in the process of in the contact process, which is vanadium pentoxide. Contact process is a process used in the industry to manufacture sulfuric acid, where sulfur dioxide, which is SO2, is converted to sulfur trioxide, SO3, in the presence of the catalyst, vanadium pentoxide, and the sulfur trioxide is later on absorbed in the sulfuric acid, concentrated sulfuric acid, to form oleum, which is diluted to make sulfuric acid. Dehydration is the same as drying, removing of moisture or water from a substance. Dust collection. This is a process of capturing, trapping, removing dust from this off gas. So the off gas, the gas that we receive from smelter department, comes with quite a lot of metallic dust. So we have a section also called dust collection, which uses electrostatic force, electrostatic precipitator to capture the dust. Electrowinning. This is a special type of electrolysis where we use electricity, direct current, to recover a metal from a solution. So instead of throwing away the dust, we'll get that dust, we'll dissolve it. Acid digestion, we'll dissolve it, leaching it. That solution, we filter it, then we pump it to the tank house called electrochemical cell, where we have electricity and electrodes there. Then copper, in this case, will start growing from the cathode electrode. From the liquid, we recover a metal from the liquid. Pollution control. These are techniques, methods, technologies we are using to eliminate, reduce the emissions, the releasing of pollutants into the environment. Pollution control is very much important. We cannot exist without the environment. We need to protect the environment, not only the environment, but also the community. We have communities around CCS, farmers. We do not want their maize affected. So we should always be safety conscious, environmentally friendly in the way that we are operating and designing our operations. Exothermic. So the exo, it's out. The thermic part is coming from heat. So this is a type of chemical reaction which gives out heat to its surrounding. We also have endothermic, the opposite of that. So this is a type of reaction, chemical reaction, which will inside hazardous, coming from hazard. That term refers to something that has potential to cause harm or risk of harming us. Danger. Neutralization. This is a chemical reaction involving acid and a base or an alkaline to make salt and water. In simple terms, trying to make something neutral. So allow me to also jump into number 13 to connect the two. We have pH. So pH, this is a measure of acidity or alkalinity. So we have a pH, the range from 0 to 14, and 7 being the neutral. Oleum, same as fuming sulfuric acid or pyrosulfuric acid. This is a solution of sulfur trioxide in concentrated sulfuric acid. And when we expose to the air, we'll actually see some white fuming. It is a product of sulfur trioxide and concentrated sulfuric acid, which we later dilute. To dilute is to lower the concentration by adding more of another solvent. In this case, acid plant, we are using water to dilute oleum to the desired concentration of 98.0 to 98.3%. Oxidation. Oxidation is the addition of oxygen, adding of oxygen, or removal of electrons from an atom or a molecule. We have SO2, which we need to make SO3. So we are adding, here we have 2 oxygen, there we have 3. Purification. Purification is a process of making something pure or making something clean. This is a very important process in the production of sulfuric acid, where we need to ensure that our raw material, our primary raw material, and our secondary raw material is well purified, cleaned, without impurities, removal of impurities or contaminants. Safety. These are measures, protocols, precautions that are put in place to protect the environment, individuals, equipments from possible danger, from hazards. Sulfur dioxide, when we burn elemental sulfur or sulfur containing materials, we produce this pungent, colorless gas called sulfur dioxide. When we get this SO2, we add more oxygen, we oxidize, we get sulfur trioxide. The last one is sulfuric acid. Sulfuric acid is a colorless, oily, very corrosive chemical with numerous applications. It is used in so many industries. Quickly, I'll try to run through now the equations of sulfuric acid production. So this is the contact process. We have sulfur dioxide gas plus oxygen gas in the presence of catalyst vanadium pentoxide to give us sulfur trioxide. This type of a reaction is exothermic reaction, one that almost about 100 kilojoules per mole of energy is given out in this reaction. Apart from being exothermic, the first equation is also reversible reaction or equilibrium reaction. In a case where the conditions are not properly managed, the formed sulfur trioxide can be taken back to sulfur dioxide and oxygen. So it is very important to ensure that the right conditions are at all times followed for maximization and optimization of our process and our production. The sulfur trioxide that is formed is absorbed in liquid sulfuric acid, concentrated sulfuric acid, to form oleum, fuming sulfuric acid, which quickly dissolve dilution with water to create two of sulfuric acid. If you've seen here, it's one of oleum, one of water. We have two of sulfuric acid. So we use water to dilute to make sulfuric acid of desired concentration. In our case, we are talking about 98%. So briefly, this is the flow chart where we have gas from smelter. We purify it, purification, we clean it, we remove all the impurities, we dry it. Then here we convert it, addition of oxygen. So this is oxidation, addition of oxygen in the presence of vanadium pentoxide, which is a catalyst we talked about. We are going to have our converted SO3 there. The SO3 will react with sulfuric acid to give us oleum. Oleum will dilute with water to give us our product of desired concentration, in this case, sulfuric acid. So the contact process, briefly, we have two parts: the pre-treatment of the off gas and the DC-DA. In the double contact, double absorption, we have two of the contact and two of the absorption. The contact in the sense that this SO2 will come in contact with the catalyst two times. The product, which is SO3, will also come in contact with sulfuric acid two times. So this is the dust collection section I was talking about, where we are using electrostatic precipitator to remove dust from the off gas. From there, the gas will go to gas cleaning and cooling section, where it is further purified and cooled. We have the blower, SO2 fan. SO2 fan is very important in acid plant, being the one that is there for and to facilitate the transportation of the gas by creating a negative pressure, suction, compression, and also blowing to overcome the negative pressure in the system. We have the converter section, where we have our catalyst there, vanadium pentoxide. Our conversion rate is greater than 99.65%. We have the drying and absorption section, where the drying of the gas is done and the absorption of the gas is done. The moisture content, we talked about drying, removal of water or moisture content. Using sulfuric acid, we ensure that the moisture content is less than 0.1. And also the absorption rate is greater than 99.9. We have our storage tank. After production of sulfuric acid, this corrosive chemical must be well stored. We store it in our well-designed storage tanks, of course with thickness ranging from 24 millimeters carbon steel to about 10 millimeters on the top there. The storage tank capacity, each one has, we have 9 of them, each has 5,000 metric ton. We have the loading bay. After we produce the acid, we have to load it to the tankers. We have our quality control system, the lab, acid lab, which ensures that the concentration is meeting the required standard. All the effluent, the waste acid, is taken to this plant, waste acid treatment plant, where we treat it, we neutralize with lime to create gypsum and water. We also have the copper recovery plant, which we are calling bismuth leaching plant, where we, from the dust that we collect from dust collection, we make the solution, we leach it, we filter it, we precipitate to make the compound bismuth oxchloride. We also have the same one, we filter the filtrate, the liquid that comes out, that is copper sulfate. We take it to the tank house there for the production of copper cathodes. That we are dealing with a very corrosive chemical. Safety is paramount, very critical. That is the required protective equipment for acid plant. Here are some of the few points to enhance safety in sulfuric acid plant. We do have a comprehensive risk assessment where we do risk assessment for the whole plant. We identify the hazards that are there and put in place the necessary control measures. We also have PPE, personal protective equipment, and it comes as the last option because first we try by all means to eliminate the hazards that are there. If we cannot eliminate, we'll try to use some designs, engineering, ways in which we can eliminate the hazard. We also have comprehensive trainings and education. We have emergency preparedness and response, robust safety system, standard operating procedures. We don't just do things. We are guided by the standard procedures. When we have such an emergency, we have such a procedure that must be followed. Monitoring and control of the process, very critical. Hazardous material storage and handling, very important. Regular inspection and maintenance of our equipments and also audit. The nature of acid plant, we are dealing with a corrosive chemical. Our equipments over time tend also to be affected. So maintenance, very important. Shutdowns, very important. We also foster a culture of continuous improvement. We ask, how do we do it better? Regarding and relating to safety measures, how best we can handle this in a safe and better way. That is one of the safety drills that we do to prepare and refresh the minds of our operators. We conducted one which was a very successful one and a very colorful one. The importance of sulfuric acid. Why is sulfuric acid plant important? We are a key provider of this wonderful chemical called sulfuric acid. One that is versatile, indispensable chemical that supports quite a lot of industries. We can talk about promotion of agriculture, facilitation of mineral extraction, enabling synthesizing of products, chemicals, talk about environment, protection of the environment, treatment of water. We all need sulfuric acid. In conclusion, we have 4 main sections in sulfuric acid plant. That is a dust collection, acid making, waste acid treatment, and electrowinning section. The 2 major processes that we are using in acid plant is the off-gas treatment, pre-treatment, and the double contact, double absorption. We also have the acid making section, which is the largest one, where we have gas screening, drying and absorption, and converter as the major sections of sulfuric acid making section. The raw materials for the production of sulfuric acid, those are the raw materials that we need. We need sulfur dioxide, we need oxygen from the air, and of course we need water. Those are the chemicals, the chemical formulas. The one which talks about sulfur dioxide reacting with half of oxygen gas to give us sulfur trioxide, with of course releasing of energy in heat form. We have sulfur trioxide reacting with water in sulfuric acid to give sulfuric acid. The last part is the neutralization reaction, where we neutralize the acid with lime here to give us gypsum. The 4 products that we produce as sulfuric acid plant is 98% sulfuric acid, bismuth oxchloride as a compound, gypsum, as well as cathode copper. Do we have questions? You're asking ways, means and ways to, good idea, to save electricity. Yes, acid plant is one department or one facility that consumes quite a lot of energy because of the processes that are involved. We are still incorporating new technologies on how best we can effectively save energy in terms of improving on insulation to protect the loss of heat. Also, in future, maybe we can look at alternative means. For example, converter section. We do incorporate quite a lot of systems which help us to save energy, not only during startup, but also during short shutdown. We save energy, not letting it go to the environment. Thank you very much. 谢谢。